The discussion is about the generation of AC current. As you know, in accordance with Faraday's law, where there is a change in magnetic flux through a conductor, there induces voltage in the conductor. This voltage is also known as EMF, electromotive force. Only when there is a variation of magnetic flux through a conductor, there we expect the voltage in the conductor. As we already know, the magnetic flux is, it is AB cos theta. The symbol is phi. AB cos theta is called as magnetic flux, where A stands for area of the conductor through which magnetic field is passing through, and B is the strength of the magnetic field, where theta is the angle between the area vector and magnetic field vector. AB cos theta is magnetic flux. When it changes with time in a conductor, that is change, for the change you have to differentiate the function with respect to time. It is same as d by dt of pi. There should be a rate of change of magnetic flux with time. Then only we realize voltage in the conductor. The voltage in the conductor is epsilon. It is also called as EMF. For this change, what is that? For a change, that is d pi by dt, rate of change of magnetic flux with time, and the magnitude of this rate of change will decide what magnitude of voltage is induced. Higher the rate of change, higher is the voltage induced in the circuit. For this change, for a change in magnetic flux with time, we need a device. The device is here. The device, see that a device has two items, two things. One is the conductor, other is the magnet. What is the two things, magnet and the conductor? For this change, for this d by, that is for this change of magnetic place, one thing should be fixed and the other is set for a continuous motion. Continuous motion means it is not linear motion, it is rotational motion. Since rotational motion is localized, linear motion is not localized. One which is fixed is called as stator, other which is set for motion is called as rotor. Stator, rotor. Stator, rotor. There are two designs. The designs are here mentioned. In these designs is a combination of conductor and magnet. In this design, the rotor is a conductor, This is a conductor. The rotor is a conductor. And the conductor what you have taken should be in the form of coil. The coil can have a shape of a rectangular shape, circular shape, or elliptical shape. The purpose of taking the coil in this coil shape is to have what is that area of cross section, certain area of cross section. This is area of cross section of the conductor. That is the reason you have take it in the coil form to have more area of surface. And the coil is a rotor, magnet is fixed. In this design, magnetic field or magnet is fixed. It is a stator. Magnet is stator and conductor is rotor. It is rotating about its axis. For this rectangular shape. In this design difference here, the stator is conductor, rotator is magnet. Magnet is allowed to rotate and the conductor is fixed here. The conductor shape is a circular coil is circular shape and you are taking very large number of turns. The wire is wounded over this, large number of turns are there. The purpose of taking a large number of turns here, the voltage induced in the circuit also depends on the number of turns, N. That is why we have a certain large number of turns. The coil with a number of turns to increase the voltage induced in the circuit. Of course, I have shown only one turn. Here also I can have many number of turns to have this coil. The design difference is like this. Here is the design. This design is, and this outer stator is the cylindrical shape, and inner also cylindrical shape. In this cylindrical surface, in this cylinder, inside, that is inner surface, the coil is fixed. And inside the cylinder, there is magnet is fixed, which can rotate about the axis of the cylinder. Which can rotate, this can be rotated about the axis of the cylinder or the line, vertical line passing through the magnet like this. Rotator. This is a rotator here. This is a design. The purpose of their design is that during the rotation, while the rotor is rotating, either this is a rotor or this is a rotor, what happens? There we see what is the rate of change of magnetic flux with the time in the conductor, in this conductor. Rate of change of magnetic flux with time in this conductor, here in this conductor here. When there is a rate of change of magnetic flux, definitely there induces voltage epsilon in this circuit and in this circuit, the circuit like this. That is the purpose of the design. And it is in this activity, overall they are mechanical energy, rotor as a mechanical energy, rotor as a mechanical energy. It is a mere conversion of mechanical energy into electric energy. Electric energy appears in the circuit. And what the electric energy appears in the circuit is in the form of AC cycle. What is AC cycle? Alternate positive, negative, positive, negative. Changes positive, negative, positive, negative. changes periodically. Here also positive, negative, positive, because here the design, what is that? The terminals of the conductor is connected with this design, slip rings with brushes like this. You see alternate, plus minus, plus minus, plus with this rotation. Periodic changes. Periodically changes plus and minus, plus and minus. Why periodically changes? The reason here, during the rotation, there is a periodic changes in north and south pole. This is rotating north and south pole with respect to conductor. Periodic changes in north and south pole, or periodic changes in the magnetic field and its direction. Magnetic field and the direction changes periodically. Periodic changes in the direction of the magnet. That is why we have plus and minus. For one direction plus, other direction minus. This is keeping periodic changes. That is why we have only AC cycle in a circuit with this design. The design is, what is that? In this design, whether the design is this or this, the mechanical energy changes into electric energy or electric power. That electric power is transmitted only in one direction. We have why now? After winding, we have endings, two endings. Winding, number of windings, we have two windings. But we have the conductors, there are two conductors per circuit complete now. Passing through for a complete circuit, we have windings. But the energy is always transmitted in only one direction. And the energy transmitted to the conductor, it is called as a phase in this direction, suppose it becomes a phase. And the other conductor, it is only for just a return, cycle. So every conductor has, what is that? For a conduction requires complete circuit. After this circuit, it is for a return, neutral. Where neutral does not carry any power transmission. So power is transmitted, or energy, what energy? Electric energy is transmitted only through one wire, one direction is called as phase, other is called as neutral. This phase, neutral. Here we get single phase AC by this design. Single phase AC by this design. I said electric energy is generated by the action of mechanical energy. We need a mechanical energy for this rotation, Where we get this mechanical energy? We get it from the nature. Because in nature, abundance of kinetic energy is available. You have different types of kinetic energies. Kinetic energy in the form of water flow from higher level to lower level at waterfalls. Just imagine that. What is the powerful? That is, water flow is a powerful kinetic energy from higher to lower, where we can have hydroelectric project. And also, wind blow. The blowing of wind also has kinetic energy. You can have the power generation for this blow of wind. And also we can get kinetic energy from the thermal energy or heat energy. This heat energy is also available but is stored up in certain materials. The thermal energy is stored up in petroleum fuels, that is petroleum product, diesel, coal. It is stored up as chemical energy. We can tap out that energy by burning the fuels, that is heat energy. This heat energy is also stored up in nuclear fuels, that is enormous amount of energy is stored. That also can be tapped out by carrying out nuclear reactions. Heat energy is liberated. The thermal energy thus liberated can be converted into kinetic energy. It is possible. Finally, we have a source, abundant source of kinetic energy in nature. It is possible to convert the kinetic energy into mechanical energy by a device known as turbine. That is a rotor turbine. It is getting rotated by the action of this kinetic energy. So the turbine, if you connect to this rotor, either this rotor or this rotor, it is continuously rotated. It is continuously rotated. The mechanical energy is continuously available energy. So there is a continuous generation of AC current. Continuous generation of AC current. So that is the purpose of the device. And AC cycle or AC current generated in the circuit, it is in the form of, that is a cycle, AC cycle or wave like this. It is called as one wave. It is called as one cycle of AC. This is generated by one rotation, single rotation of the rotor. I said it is a variation of voltage. I said voltage variation is plus or minus. Voltage variation because of variation of magnetic field. That is a regular periodic variation of EMF or induced. That representation of voltage variation like this EMF, it increases, reaches the maximum, decreases, again zero, again further in the opposite direction, negative direction. It decreases, reaches minimum, increases, again this. For this is one cycle of wave, or this is called as one wave. It is generated by one single rotation. Why this variation? It is a variation. It says that it is a variation of EMF or voltage in the conductor due to variation of magnetic field. I'll explain with this. During the rotation of this magnet, one body, suppose when the N is here, the point we realize this. When is what is moving towards this and comes here, it is an increase like this, increases, reaches the max. It is a direction of maximum flux passing through this coil when the position is here. And with continuous rotation, and when rotating from here to here, the variation of field from here what is it decreases again the other point, realize here. When N begins to rotate from here to here, it is a variation in opposite direction. Reaches this negative voltage. When N rotates and comes back here, it is like this. For one complete rotation of magnet, we have one complete cycle of AC, showing the variation of magnetic, variation of voltage in a conductor. It is for one rotation. Now it is not one rotation, it is a continuously rotating, we produce a number of rotations. See that how the AC is generated in the circuit, one wave and one more wave for another rotation, one more wave for one more rotation, one more wave for one more rotation. Like this, the AC cycle is generated, showing the variation of EMF with time like this. And finally, it is appearing in the form of electric power in the circuit. If there 50 number of cycles are generated, 50 waves are generated in 1 second. 1 second, that is called frequency of the AC. 50 cycles or 60 cycles are generated in 1 second. It is because of the rotor is rotated 50 times in 1 second. This frequency and this frequency remains. The frequency of AC cycle is same as frequency of the rotation, speed of the rotation. Frequency of the AC generated is directly related to the frequency of the rotation. Higher the frequency, higher the speed. Higher the speed, more is the mechanical energy converting into electric energy, higher frequency like this. So this is how the electric energy or AC is generated in the circuit by this device. I said the equation says that the amount or magnitude of voltage induced in the circuit, it is not only depending on the speed of the rotator, it is also depending on the values of A, B and N. Values of A, B and N. Here the values of A and B and N are constant for the device once it is constructed. Cannot change, cannot remove, because it is the area of the coil. It is fixed inside, never be changed. And the intensity of the strength of the magnetic field, it depends on the magnet. Powerful magnet, that is maybe permanent or electromagnetic you can use. Once for all you have to use the value of B. And number of turns, maximum possible number of turns. Take precautions to have high values, as high as possible values of A, B and when before it is being constructed. And next is, it is depending on the speed of the rotation. Speed of what is the turbine you are using related to change in magnetic flux. The voltage is induced in this. So this is how the device keeping in mind the design, so that we have maximum, what is that? Maximum change in the rate of change of flux with time. Therefore, maximum voltage is produced. That is the design we required for the construction. In this design, we have a stator with one coil, one magnet. But the same design we have made some what is that progress or what is that improvement in this design. Here one more coil, the single coil. A difference here, instead of taking out this wire here, this wire is extended, this again giving large number of turns and come out as a neutral. Here remains as a phase. With this pair of rings, with this magnet, same design, look at that during rotation, this is during rotation due the same cycle of AC. Same cycle of AC. What difference you are finding? The difference here this wave, what is the output wave? This is called as output. AC output, this wave, quality of this wave, here we are realizing more quality of wave can be expected by this design than this design. More quality means that is voltage fluctuation. What is that? This is the voltage variation. So we see that we are minimizing the voltage fluctuation in generating AC here and AC here. Becomes the quality of the wave is improved by having this design. Once we have a design, we can further improve the design to have a quality of, or what is that, quality of AC output, AC frequency and efficiency of energy transfer from mechanical energy into electric energy. This is of course the generator having only single phase generator. Single phase generator with a pair. What is that? We call pair means two slots, two poles. What is meant by two slots? Two poles. two poles means one magnet have two poles. Two slots means two coils. One slot, two poles. One coil, two poles. This generator is a single phase generator. We can have even three phase generator in the next stage. Let me explain in detail about the generation of the electric current in three phase. This let us stop for a while.